In this video, we are asked to do what? Solve the differential what? Equation. Now remember, in differential equation we have so many techniques we use to do what? Solve them. Okay? Now first thing to check what is whether the differential equation is what? Is separable. If it's separable, we can use what? Direct integration method to solve it. Now looking at the problem given to us to solve, okay, recall that differential equation is separable if it's of the form y prime equals what? F of x times what? F of y. Okay? That means whenever differential equation is of this form, that differential equation is separable because we can separate what? Function of what? X in terms of what? Function of what? Y. Now looking at the equation given to us, you see that the numerator is what? F of y, and the denominator is what? In form of f of x times what? F of y. So this differential equation is what? Is purely what? Separable what? Equation. So when we separate it, we can use our what? Direct what? Integration. Now, we are given dy over dx is equals what? F 4y all over what? All over what? X multiplied by what? Y take away 3. Okay. Now we can separate what? This is function in terms of what? 1 all over what? X multiplied by what? Let's just say 4 over x multiplied by what? Y all over what? Y take away what? 3. Okay. So this 4 over x is like what? F of x. And this y over what? Y take away 3 is like what? Function of what? X. So the equation is what? Is separable. So when we do that, we can separate that. We can take what? Y over what? Y take away 3 to go to the other side to meet what? Dy. And what? We take dx to meet what? 4 over what? 4 over x. Right? So when we do that, we're going to have y. We're going to have y take away 3 divided by what? Y. Okay. Dy is equals what? 4 over what? X d what? Dx. Okay. So integrating both sides, we're going to have something like this. You see that we have separated the function of what? Y in terms of what? Function of what? X, right? So when we split this, okay, we're going to have what? Integral of what? Y over y, take away what? 3 over what? Y, with respect to what? Dy, which is equals what? Well, we can bring out this 4 outside. We're going to have what? Integral of 1 over x what? Dx. Okay. So when we push this further, we're going to have integral of what? 1, y divided by y is what? Is 1. So we're going to have what? Integral of dy, then take away what? We can bring 3 outside, we have what? Integral of 1 over what? Y dy, dy, which is equals what? 4 integral of what? 1 over x dx. Now, of course, you remember from your differentiation that when you differentiate what? Ln x, or when you differentiate ln y, it will give you what? 1 over what? Y. The same thing, once you integrate 1 over y, it will give you back what? Ln y. Okay? Because integration is just what? Reverse of what? Differentiation. So when we integrate this, we're going to have what? Y. Okay, take away what? 3. Integrate 1 over what? Y. We're going to have what? Ln what? Ln y, which is equals what? 4, when you integrate 1 over x, you're going to have what? Ln what? Ln x, then plus what? Our constant what? K. Is that okay? Or let us just see at this point. Okay. Now, from here now, we're going to have y is equals, let's put this one to the other side. We're going to have what? 4 ln what? X. Then this process becomes what? Plus 3 what? Ln y, okay, plus what? C. Now let our C becomes what? Ln what? Maybe ln k. Okay, want to transform this to become what? In terms of length. So we can couple this together. Is that okay? So when we do that, we have y is equals. Now, from logarithm, you remember that when we have something like log a raised to the power of n, okay, this n will come down to multiply the log. So we're going to have what? N what? Log a, right? So the same thing is applicable. We can equally take this what? N back to what? Its origin, right? Now remember that ln is like logarithm to what? Base e. Okay, so it has the same property of what? Logarithm to other bases. So when we take this 4 up, we're going to have ln, okay, x raised to the power of 4, plus this 3 will also go back. We'll have what? Ln what? Y raised to the power of 3. Okay? Plus what? Remember we say let's see the what? Ln. Sorry. Okay? Ln what? K. So when we couple this together, we're going to have what? Ln. When we have addition in logarithm, what does it entail? We'll multiply what? Their numbers together. So because of this addition, we're going to multiply x raised to the power of 4 times what? Y raised to the power of 3 times what? K. So we're going to have what? X raised to the power of 4, okay, times y raised to the power of 3 times what? Times our constant, okay? So finally we're going to have ln k x raised to the power of 4, y raised to the power of 3, okay? So here our y is simply means what? Ln what? K x raised to the power of 4, y raised to the power of 3. Now remember that the base of this ln is what? Is exponential, because when we have ln what? X is equals let's say a, it simply means that x is what? Equals what? Exponential raised to the power of what? A. So the same thing is applicable. K x raised to the power of 4 times y raised to the power of 3 is equals what? Exponential what? Exponential y. So this becomes what? The solution to this. So when we solve this, we're going to have this. Okay? So in our next video, I'm going to teach you how to do what? Solve what? Differential equation using what? Other techniques. Thank you.